Hello. In this example, we are going to graph f of x equals 2x cubed plus 3x squared minus 11x minus 6. When we do this, the first thing we want to do is we want to find the possible rational zeros first. In this problem, p is in this case, 6, so p is associated with 6 here, and 2 is the leading coefficient, and that's 2. So the factors of 6 are 1 and 6 and 2 and 3. The factors of q are 1 and 2. So we're going to write down every possible rational zero, starting with every possible p over q. So that's 1 over 1, 1 over 2, 2 over 1, 2 over 2, 3 over 1, 3 over 2, and 6 over 1, 6 over 2. Then we need to simplify this. 1 divided by 1 is 1. And I'm going to do plus minus as we go along. 1 divided by 2 is a half. 2 divided by 1 is 2. 2 divided by 2 is 1, but we already have it. 3 divided by 1 is 3. 3 divided by 2 is 3 halves. And 6 divided by 1 is 6. But 6 divided by 2 is 3, and we already have it. So there we go. These are all of the possible rational zeros. Fantastic. Now, the next thing we want to do is we want to find all of the zeros and their resulting multiplicities. To do that, however, yes, we could just randomly guess and check out of the possible rational zeros, but it's almost always going to be easiest when you graph it. So, go to y equals, clear out anything in here using clear, and type this in. 2x cubed plus 3x squared minus 11x, oops, I messed all that up, didn't I? 2x cubed, and don't forget to do the right arrow there, plus 3x squared minus 11x minus 6. Fantastic. Now, you can press zoom 6 or graph either one just to look at this. So I'm going to press zoom 6 here, just to make sure we're on the standard window. And here's what the graph kind of looks like. Now, I'm looking for zeros. So I'm going to go to my table, so press second table. Again, notice I'm starting at -5 because if you remember from the previous video, I changed the table set here to start at -5. So I'm going to go back to my table here. And I do see a 0 here. That 0 is at -3. But again, you can't just say, well, by the calculator, -3 it doesn't work that way. You have to prove it. And so proving it is easiest using synthetic division. So take that -3 and plug in these values. 2, 3, -11, -6. Bring down the 2, multiply, add, multiply, add, multiply, and add. If you didn't get a 0 here, one of two things happened. Either you typed in the function wrong, or more than likely you messed up somewhere in here. Okay, fantastic. Now this is a quadratic, which means I could set it equal to 0 and solve. Absolutely, no problem with that. However, let's go back to the table. And I don't see any more zeros, but notice that it only goes to 1 there. So I'm going to use the down arrow and scroll down. Oh, look, there's a 0 right there. That 0's with the 2. So I'm going to prove that 2 is a 0 using these 3 numbers as well. So bring down the 2, multiply, add, multiply, and add. Fantastic, we've just proven that 2 is a 0 because the remainder is 0. And the two numbers here are just a linear function that gives me 2x plus 1. If I set that equal to 0, I subtract 1 divided by 2, so x is negative a half. So now I have my zeros, negative a half, 2, and negative 3. So I'm going to make a bit of a table here. 0, the multiplicity, and the behavior. Fantastic, there are 3 of these, so the farthest one to the left is the negative 3. The next one is negative a half, and the next one is 2. Now if you look at these, the number of times that we've used each one is just once. So the multiplicity for each one is just 1. Therefore, it crosses. Because the behavior depends on the multiplicity. If it's a 1 or an odd, it crosses. If it's an even multiplicity, it bounces. AKA it doesn't cross, just kind of touches the x-axis and goes the other way. Fantastic. Now the next thing we need is the y-intercept. Now, the y-intercept is not hard to do for this question. You just plug in 0 for all the x's, and what are you left with? Well, you're left with negative 6. So that means that your y-intercept is 0, negative 6. And there's one more thing we want to do. We're going to find the end behavior. To find the end behavior, we're going to look at the degree of the exponent, or the degree of the function. Now, looking at this, the degree is 3, which is odd. Therefore, it either goes to the left, goes down to the left and up to the right, or up to the left and down to the right. It goes to opposite sides. So because of that, and the 2 is positive, it's actually going down to the left and up to the right. Fantastic. Now we have everything we need in order to graph this. So I'm going to graph the negative 3. 1, 2, 3. Graph the negative a half. Right there. Graph the 2. And graph my y-intercept, 0, negative 6. 1, 2, 3, 4, 5, 6. Good. And again, we need to look at the end behavior. To the left of the first 0 here, we're going down this way. To the right of the last 0, we're going up, like that. And at each of the zeros we cross, so I'm going to go up this way, down that way, and up that way. And then just kind of connect everything. Make sure you go through that point. And just kind of connect up. Fantastic. Now, here's the graph that I've just created. But realize this is not what this looks like. Well, helps if I go to the graph, doesn't it? Here you go. That's not what this looks like. But that's fine, because I'm not really worried about where does this turn back to back down this way, and where does this turn back up here. What I'm worried about are what are the zeros, what's the y-intercept, did you get the end behavior correct, and did you get the behavior at the zeros correct? Now notice that getting the behavior at the zeros correct, and getting the end behavior correct, and making sure it goes through all the points, it's almost self-correcting, because you're going to kind of see if you make a mistake. For example, if you actually bounced back down here and then you crossed up here, well, there's no y-intercept up here. And so because of that, here, let me show you. When you were doing this, if it looked like this and bounced back down and then you crossed, there's no way to get back down to your y-intercept here. And so you'd be going, ooh, and then, oh, there has to be another 0 there to get down to this point. So this is almost self-correcting if you are very careful when you're graphing. Alrighty. Well, have fun. I'll see you in the next video.